Now we want to focus on how to discretize this equation, of course without the a. Using the finite difference method. What is the order of this differentiation? There is a ddx here and another ddx here. So it's second order derivative. How do we approximate second order derivative? We use central difference approximation, right, to the second order. And I'll jump into this slide. This is where I introduced it using the graphical method, right? And I said the second order derivative using central difference basically involves, this is x, and this is x minus delta x, this is x plus delta x. It involves a central term here, I mean a midpoint here. So you use these 2 points. So find out f prime. You're looking for f prime prime, right? Second derivative. Find out the first derivative at x minus delta x over 2 and x plus half delta x, right? So use these 2 points. The f prime, the first order derivative at these 2 points. That's what these two are. Take the difference and it's going to be divided by delta x. Why isn't it 2 delta x? It should have been 2 delta x, but the delta x we're using is half of delta x. So 2 times half of delta x gives you 1 delta x, which is why this is here. So this is the concept we are going to use. Then we will now find each of these terms, right? One after the other, using central difference a second time. So we're looking for f prime prime. So this is the first term, right? And how do we get a central difference approximation of the first order to this? We're going to do f at x plus delta x, because we're going to go half delta x again. Add half delta x to this and subtract half delta x from this. So x plus half delta x over 2 plus half delta x over 2 is the first one, and the second one is, why is it showing z? No, it's over 2, right? Delta x over 2. Half of delta x, half of delta x. This is half of delta x minus delta x over 2. What's that? This goes away. So x, that's this one. And this one is 2x, right? I mean, x plus delta x. Am I missing something there? Yes, it's going to be x plus delta x, because delta x over 2 plus delta x over 2 equals delta x. But delta x over 2 minus delta x over 2 is 0. So this is x, this is x plus delta x. And that's why this x plus delta x goes in here, this x goes in here. Do the same thing for this. X minus delta x over 2 minus delta x over 2. Minus minus becomes x minus delta x. That's this one. And the other is plus delta x over 2. So minus x over 2 plus delta x over 2 cancels, and you're left with f of x. That's this. So using those two, substitute those two into the equation from the previous slide, right? This. So putting that one there, putting the second one here, and then you get the expression for, why is this keeping 2? Then you get the expression for f prime prime x. This is the idea we will be using for the discretization. So to show it step by step, because the final result is what you see right here, right? This is how we do it from scratch. So I'm just going to create a new Actually, I have these equations, right? The governing equations here. You can just do it for one of them, say for oil. So again, you could multiply both sides by area. I choose not to, because you don't have to. And now we want to use the finite difference approximation. Let's focus on this left-hand term. I want to focus on just this for now. You know, you can write that equation in this form: d dx of f, where f is everything here. All right, so this is f. Just for brevity, we call that f. And that will be what? Using central difference, it will be f at x. Let me check the nomenclature here so I stick to it. xi plus 1, xi minus half. So I use exactly that. F at x said xi plus 1, right? F at xi plus 1 minus f at xi minus 1, right, over 2 delta x. This was the standard form of the central difference approximation. But we said we're going to work in terms of I plus half and I minus half, right? The original form, which is what I looked at just now. So we will say xi plus half, right, minus f at xi minus half divided by what? Because we're looking at I plus half and I minus half, delta x is now, maybe I can show it here. This is x at I. This is I minus 1. This is I plus 1. So this is delta x, right? So when you choose, maybe I can use this as the intermediate one. When you choose I minus half, right, and here I plus half, then this will be delta x over 2. So 2 times delta x over 2 is what you're going to have here. So 2 times delta x over 2 will be what? Delta x. So these two are equivalent. And again, because I only showed you this part where we used I minus half and x plus delta half, I want to show you that if you, where is it? Central difference plus delta x. Right here. So this is the first version, right? It's 2 delta x because we're looking at x plus delta x and x minus delta x. So it's spaced out by 2 delta x. We're using 1 and 3. Then it's 2 delta x. That's the first version here. Spaced out by 2 delta x because you're looking at I plus delta x, that's delta x away, and I minus delta x, another delta x. So 2 delta x is what you divide by. But when you choose to use I minus half, I plus half, you will be dividing by delta x, and that's the second form of the equation. Is that clear? Good. I think I'm going to have to stop here, then record another video to continue from there.